Dear TRIZ enthusiasts, this presentation was given by me at the third German TRIZ Conference in 2024. My name is Adunka and I am a TRIZ Master in Germany. For the international audience, I recorded this presentation also in English. Function analysis is one of the TRIZ tools that has captivated me since my first invention machine course and has not let go since. I think it's a tool that should make it easy for anyone to describe and understand their technical system. The intention behind function analysis is to develop a common understanding of the system under investigation and to understand the interdependencies. Development tasks should then be derived from the knowledge of what our system can do well and can not do so well. This premise of analyzing and defining tasks should always be kept in mind. So what is the main goal behind my function analysis? What do I want to achieve with it? In addition to the function analysis, a whole bunch of rules and guidelines were developed by a lot of people in order to improve the system. However, they always did this against the background of their personal problems and the personal working environment. And then the argument began about who was right. In my presentation, I would like to make an attempt to explain the world of function analysis and all the disputes surrounding it, and to put it into a framework that allows me to reconcile all points of view. I will therefore first switch to the bird's eye view and from there look at the function analysis and what we are doing there. Oliver Meyer once said in a presentation that they always pump in TRIZ projects. That is, they switch back and forth between detailed analysis and a bird's eye view. That stuck in my mind. Then I would like to introduce the domain-specific approach and finally discuss the functions in detail. I introduced the basic function analysis for didactic reasons in 2014. However, I did not realize at that time that I had made a separation after modeling the system and then only saw the different directions of analysis as manifestations of a single function analysis approach. I was more interested in breaking down the prevailing confusion between the various analyzing tools for incremental improvement, value analysis, or for trimming. I didn't realize at the time that I was separating modeling from analyzing. However, if we look at this from a bird's eye view, we can see the meta level behind the procedure. If we analyze our approach to function analysis, we can differentiate between two steps on a very rough level: the modeling of the system and the analysis of this model. If we look at function analysis for products, for example, the creation of a model is broken down into the steps of component analysis, interaction analysis, and function modeling. If we then add an incremental improvement, we analyze the functions and derive the tasks from the degree of fulfillment and the types of functions. This analysis is often carried out together with the modeling step, and therefore it is not noticeable that there are actually two sections here that can be considered separately. But what are the benefits of this thought? In 2018 at the TRIZ Fest in Lisbon, Simon Lidwin's presentation confused me a little. Databases inform processing units. Which parameter is being changed here? The statement was that this is done differently for information-heavy systems anyway. At the time, it seemed a bit strange to me that the TRIZ master, who is so vehemently described other function models as incorrect, dismissed this with a wave of his hand. The function model is wrong, I thought. What kind of component is external event? Does it have resting mass or is it a field? The heated discussion between Valery Sukhkov and other TRIZ masters about the correctness of functions and function analysis led me to make this the topic of the 2019 Expert Day in Germany. There, however, Valery Sukhkov described an approach that primarily relates to information-heavy systems as extended function analysis. He also uses his function model for incremental improvement value analyzing and trimming. He expands the number and types of components for the function model and allows for functions that, according to classical view, go into the wrong direction. One of the typical examples of this is the process of ordering a coffee in a restaurant. There, he would classically say that the coffee menu informs the customer. Valery couples the information functions here with a customer studies coffee menu. Why is Valery taking this approach? He has found that he cannot model some things in information-heavy systems well with a classical model. But who is right now? Who has the better function model? Why are they actually arguing about this? What helps is good? These were my questions and my thoughts about the situation. As I am a person addicted to harmony, I naturally wanted to agree to both sides. What happens if we agree with both sides? We have to define under which circumstances one way of modeling is advantageous and under which circumstances the other way is better. With Valery Sukhkov and Simon Litvin, we have seen that classical function models cope well with mechanical systems and can map them, but fail with information-heavy systems. Valery's extended function analysis works well with information-heavy systems, but would not be useful for mechanical systems. Each domain has its own specifics that need to be taken into account in order to create a model. I presented the specifics for modeling electrical systems at the Adria TRIZ Future Conference in Bergamo way back in 2010. So, if we let go of the idea that there is only one right way of modeling function models, we can set up different rules and guidelines for the different domains. Let's take a look at 3 different function models. In this picture, we see a simple model of a mechanical cutter that is used to cut a paper. We can see that all the components of the systems are components with resting mass. No fields are needed to set up this model, and the functions between the individual components mainly describe mechanical interactions. In this example of an electrical system, we see different things in the components. On the one hand, with electricity, we see a supersystem that is more field-based. With housing, we see a component that has resting mass. An Ethernet interface indicates a conglomerate of various electronic components, a circuit board and software that runs on it. Signal as a target component used in this model can be understood as a field. In terms of functions, we see that informs and supplies are mainly used in this model. And here we see the example of the extended functional analysis that Valery Sukhkov used in his presentation at the Expert Day 2019. We see that the informs functions are always paired with another function, such as the interaction between the customer and the coffee menu. On the one hand, the coffee menu informs the customer about the different types of coffee on offer, and on the other hand, the customer must first study the menu in order to obtain the information. So the customer has the active part here. If we think in terms of value analysis, the customer should actually receive the points for studying the menu. He's the active part. We also see that Sukhkov allows for various other components, such as the request or the decision, which are represented by other shapes. According to him, this model leads to much better results than classical function modeling. So, if we see that the different domains and tasks automatically lead to different adapted function analysis, why should we not try to cast what is done anyway into a form that allows everyone to choose the most suitable type of modeling for themselves? This would mean that we do not try to make the one right function modeling, but rather strive for the function modeling that is suitable for our task and for our domain. We could determine which types of components can be used and which should be avoided. We could define what counts as an interaction between these components. The interaction action touching only makes sense for mechanical components. If we consider functional grooves or printed circuit boards or software components, we can no longer speak of touching. We could also determine what is permitted as a function. In the classical function model, a parameter of the object of the function must be changed or maintained. In the extended function analysis, according to Sukhov, the inform function must occur as a pair with a passive function that describes the intention. The table is just a first draft, so this draft I am happy to put up for discussion. However, I think this is the only way to put an end to the eternal arguing about who is right. So, from classical function analysis, we know the three guidelines for an allowed function. The first states that the function carrier and the object of the function must be allowed components. If we use a domain-specific modeling, then we would also have to observe the domain-specific restrictions for those components, but no longer just resting masses and fields or combinations of both. The second guideline states that the function carrier and the object of the function must interact with each other. Here, too, we can define what interaction means in a domain-specific basis. For mechanical systems, this would mean that they touch each other. For electronic systems or software-heavy systems, logical interaction could be allowed as an interaction. Then we are still missing guideline number 3, which states that at least one parameter of the object of the function must be changed or maintained due to the function. But what is referred to as a parameter here? When I think back to my time at the Department of Design Engineering, a professor from the far north kept asking us, is this a characteristic or a property? Now I finally understand this question. A characteristic is a fixed parameter of an object and a property is a variable parameter of an object. The parameter is always combined with a value. So, if I look at the car, for example, the car has the color red and the speed 50 miles per hour. If I want to analyze the car while it is moving, then the color would be a characteristic because I cannot change it. And the speed, it would be a property. That's why I argue that we should view parameters as a combination of a property and a value. In other words, the property is the designation and the value would then be the specific value that takes on these properties. So it is not a parameter that is changed, but the value of a property based on a function. And now it is not only the case that we have a property for the object of the function, but we also have properties and characteristics for the function carrier that have an influence on our function. For example, if I look at a vacuum jug, then the jug has a certain position in the space, it has a certain shape of a hollow cylinder, and it has a certain thermal resistance for the heat. These characteristics influence the functions of holding the liquid in the jug. Thus, the position of the vacuum jug also determines the position of the liquid. The hollow cylinder determines the shape that the water takes on, and the thermal conductivity influences how well the temperature of the liquid is maintained. If we look a little deeper and take a look at the modeling tools such as OpenModelica, we can see that this fits very well with the models used there. For example, the heat transfer and temperature equalization between two masses can be described with a simple model. We also see that what we assume to be static is almost always a dynamic process. Ferguson, Naum, and Oleg and Simon Litvin, have thought this through to a certain extent with the advanced functional approach, but have not implemented it as consistently as we can see it here in OpenModelica. We could transfer now our functional models to OpenModelica models in this way. This would allow us to model a technical system and then simulate it. Whether we make this effort depends on the nature of the task and the expected results, but in principle, it is possible. So, with the meta level of function analysis we have seen, we basically take two steps, namely building the model and analyzing the model. These two steps can be considered and optimized separately. By separating them, we have the option of adapting them to our requirements. The domain-specific function analysis solves the problem that we have to determine what is the correct functional analysis. Depending on the task and the domain, a customized version of the function model can be made. Finally, I tried to shine the light on the function between the function carrier and the object of the function in a deep dive. Parameters should be treated as properties with values, and the characteristics and properties of the function carrier should also be seen, as these also have an effect on the function. I hope you had fun with the presentation and learned something new. The corresponding paper will be published in the Springer Publishing House within the next few months. See you!